Good morning everyone. My task in Analytic Geometry, Math 107 is to discuss my answer in Module 1 exercises 1 to 3. Before we continue, I would like to introduce myself first. I am Jan May D. Alamag, student from CED-06-301A, your discussant for today. So let's proceed to exercise number 1. Locate the following points using a Cartesian plane. Number 1, point 1. 1, negative 2. X is 1 and y is negative 2. A positive and negative. So it means that this point is located at quadrant 4 as shown in the picture. Number 2 or point 2 is negative 1, 4. Negative 1 is x and 4 is y, a negative and positive pair. So it follows that this point is located at quadrant 2 as what is shown in the picture. Next is number 3. Point 3 is 0, negative 5, wherein 0 is x and negative 5 is y. Then it indicates that this point is located on y-axis. Let's continue to number 4. Point 4 is negative 3, negative 1. X is negative 3 and y is negative 1, where the ordered pair are both negative, in which it implies that its location is located at quadrant 3. Last, number 5. The point 5, 2. X is 5 and y is 2. Both of the ordered pair are positive. Then, it means that this point is located at quadrant 1. Let's proceed to Module 1, exercise number 2. Locate the given pair of points in a Cartesian plane using a graphing paper and determine the distance between the following points using the distance formula. Use short bond papers for your solution and attach your solution paper upon submission. Check your answer by measuring their length using a ruler. In this exercise, we will be using the distance formula. Distance formula is equals to square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. Number 1, p sub 1, 1, negative 2, and p sub 3, 0, negative 5, where 1 is the x sub 1, negative 2 is the y sub 2, 0 is the x sub 2, and negative 5 is the y sub 2. So, let's plug in the given to the formula. The distance of p sub 1, p sub 3 is equals to square root of 0 minus 1 quantity squared plus negative 5 minus negative 2 quantity squared. 0 minus 1 is equals to negative 1 quantity squared. Negative 5 minus negative 2 is equals to negative 3 quantity squared. Negative 1 quantity squared is equals to 1. Negative 3 quantity squared is equals to 9. Square root of 1 plus 9 is equals to square root of 10, and it approximately equals to 3.16227. Therefore, the distance of p sub 1, p sub 3 is equals to 3.162 units. Let's continue to number 2. P sub 2, negative 1, 4, and p sub 8, negative 2, 2. X sub 1 is equals to negative 1, y sub 1 is equals to 4, x sub 2 is equals to negative 2, y sub 2 is equals to 2. Distance of p sub 2, p sub 8 is equals to, let's plug in the given to the distance formula, is equals to square root of negative 2 minus negative 1 quantity squared plus 2 minus 4 quantity squared. Negative 2 minus negative 1 quantity squared is equals to negative 1 quantity squared. 2 minus 4 quantity squared is equals to negative 2 quantity squared. Negative 1 quantity squared is equals to 1. Negative 2 quantity squared is equals to 4. So, 1 plus 4 is equals to 5. Square root of 5 is equal to or approximately equal to 2.23606. Distance of p sub 2, p sub 8 is equals to 2.246 units. This is the last. Number 3. P sub 6, 2, 0. P sub 7, 3, negative 1. X sub 1 is equals to 2. Y sub 1 is equals to 0. X sub 2 is equals to 3. Y sub 2 is equals to negative 1. Let's plug in the given to the distance formula. Distance of p sub 6, p sub 7 is equals to square root of 3 minus 2 quantity squared plus negative 1 minus 0 quantity squared. Square root of 1 squared plus negative 1 squared, and 1 squared is equals to 1. Negative 1 squared is equals to 1. Square root of 1 plus 1 is equals to square root of 2. Wherein it is approximately equal to 1.41421. Distance of p sub 6 and p sub 7 is equals to 1.414 units. Module 1, Exercise 3. Find the midpoint and trisection points of the following pairs of points. Use short bond papers for your solutions and attach your solution paper upon submission. In this table, it shows my answer on this exercise. But before I arrive in this answer, I also solve the given through the formula. Number 1, p sub 1, 1, negative 2, and p sub 3, 0, negative 5. So, before we go to Module 1, Exercise 3. Find the midpoint and trisection points of the following pairs of points. Use short bond papers for your solution and attach your solution paper upon submission. So this is my completed table. But before I arrive in this answer, I also solve the given through the formula. Formula for midpoint: x is equals to x sub 2 plus x sub 1 over 2, y is equals to y sub 2 plus y sub 1 over 2. And next, the formula for trisection point nearest to the first point. So this is the formula for the trisection point nearest to the first point. X is equals to m multiplied to x sub 2 plus n multiplied to x sub 1 over m plus n. For y is equals to m multiplied to y sub 2 plus n multiplied to y sub 1 over m plus n, where m is equals to 1 and n is equals to 2. So let's proceed to the given number 1 or item number 1. P sub 1, 1, negative 2, P sub 3, 0, negative 5. X sub 1 is equals to 1. Y sub 1 is equals to negative 2. X sub 2 is equals to 0. Y sub 2 is equals to negative 5. So let's plug in the given to the formula of midpoint. X is equals to 0 plus 1 over 2. Y is equals to negative 5 plus negative 2 over 2. So X is equals to 1 over 2 and Y is equals to negative 7 over 2. So the ordered pair now is 1/2 negative 7 over 2. So let's solve for the trisection point nearest to the first point using the given formula, the said formula. X is equals to 1 multiplied to 0 plus 2 multiplied to 1 over 1 plus 2. And it is equals to 2 over 3. For y is equals to 1, negative 5, 1 multiplied to negative 5 plus 2 multiplied to negative 2 over 1 plus 2. And it is equals to negative 9 over 3. So the ordered pair for trisection point nearest to the first point is 2 over 3, negative 3. So let's continue to the trisection point nearest to the second point. Let's plug in, but in this time, m is equals to 2 and n is equals to 1. X equals to 2 times 0 plus 1 times 1 over 2 plus 1 is equals to 1 over 3. Y is equals to 2 times negative 5 plus 1 times negative 2 over 2 plus 1. So it is equals to negative 12 over 3. So the ordered pair in trisection points nearest to the second point is 1/3, negative 4. Number 2. It is the same with number 1, same process, and also we will be using the same formula. Number 2. P sub 2, negative 4, negative 1, 4, and P sub 8, negative 2, 2. X sub 1 is equals to negative 1, Y sub 1 is equals to 4, X sub 2 is equals to negative 2, and Y sub 2 is equals to 2. Let's plug in the given to the midpoint formula, wherein x is equals to negative 2 plus negative 1 over 2 is equals to negative 3 over 2. Y is equals to 2 plus 4 over 2 is equals to 6 over 2. So the midpoint is negative 3 over 2, 3. Then let's plug in the given to the trisection points nearest to the first point. X is equals to 1 times negative 2 plus 2 times negative 1 over 1 plus 2. It is equals to negative 4 over 3. For y equals to 1 times 2 plus 2 times 4 over 1 plus 2. So it is equals to 10 over 3. So the ordered pair for trisection point nearest to the first point is negative 4 over 3, 10 over 3. So let's continue to the trisection point nearest to the second point. So x is equals to 2 times negative 2 plus 1 times negative 1 over 2 plus 1. So it is equals to negative 5 over 3. For y equals to 2 times 2 plus 1 times 4 over 2 plus 1, and it is equals to 8 over 3. So the ordered pair in trisection point nearest to the second point is negative 5 over 3, 8 over 3. Last, number 3, p sub 6, 2, 0, and p sub 7, 3, negative 1. X sub 1 is equals to 2, y sub 1 is equals to 0. X sub 2 is equals to 3, y sub 2 is equals to negative 1. Using the midpoint formula, let's plug in the given to the formula. So x is equals to 3 plus 2 over 2. So x is equals to 5 over 2, and y is equals to negative 1 plus 0 over 2. So y is equals to negative 1 half. So the ordered pair for the trisection point, midpoint is 5 over 2 and 5 over 2 negative 1 half. So let's continue to the trisection points nearest to the first point using the formula also. X is equals to 1 times 3 plus 2 times 2 over 1 plus 2. So x is equals to 7 over 3, and y, solving for y, is equals to 1 times negative 1 plus 2 times 0 all over 1 plus 2. So y is equals to negative 3. So the trisection point nearest to the first point is 7 over 3, negative 1 over 3. So that's the ordered pair. So let's proceed to the trisection point nearest to the second point. X is equals to 2 times 3 plus 1 times 2 all over 2 plus 1. So the answer in x is 8 over 3. So let's solve for y. Y is equals to 2 multiplied to negative 1 plus 1 multiplied to 0 all over 2 plus 1. So the answer for y is negative 2 over 3. So the trisection points nearest to the second point is 8 over 3, negative 2 over 3. So that's all for this discussion. Thank you for listening.
Answer Module 1 Exercise 4. Number 1. 2x plus 5y is equals to 3. 5y over 5 cancel 5 is equals to negative 2x plus 3 over 5. Y is equals to negative 2x plus 3 over 5, or y is equals to negative 2x plus 3 over 5. 2x over 2 cancel 2 is equals to negative 5y plus 3 over 2. X is equals to negative 5y over 2 plus 3 over 2. X is equals to intercept 3 over 2 or 0. M is equals to negative 2 over 5, and that's the slope. Y-intercept is equals to 0 over 3 over 5. Number 2, x plus 2y plus 4 is equals to 0. Copy 2y over 2, cancel 2 is equals to negative x minus 4 over 2. Y is equals to negative x over 2 minus 4 over 2. Y is equals to negative x over 2 minus 2. X is equals to 2y minus 4. X is intercept negative 4 or 0. The slope is m is equals to negative 1 half, and b is equals to negative 2, or y-intercept 0, or negative 2. Next is exercise number 5. Equation of lines. Number 1. 2x plus 5y is equals to 3. 5y over 5 cancel 5 is equals to negative 2 over 5 plus 3 over 5. Y is equals to negative 2x over 5 plus 3 over 5. The tan is negative 1 over negative 2 over 5. The tan is equals to 21.801, or rho is equals to 0 over 0.380. Number 2, 4x minus y is minus 1 is equal 0. Negative y minus 4x plus 1 over negative 1. Y is equals to 1x plus 1x negative minus 1. Tan is negative 1 is equals 4. Tan is equals to 75.963, or rho is equals to 1.325. B. Slope. Tan is equals to pi over 3 reduce 180 over 5 over pi is equals to 60 degrees. 60 degrees is equals to 3 over 1, and the slope is 3 over 1, and the 3 is rise and the 1 is run. 2 point pi is equals to 1.27 reduce 180 over pi is times 1.27 is equals to 72.76 degrees. M is equals to 3 over 22 over 1, and that's the answer.
Module 1, exercises 6 and 7. So for exercise 6, identify which of the relationships between each pair of lines, whether they are parallel, perpendicular, or neither using their slopes. Number 1, we have lines 2x plus 5y equals 3 and 6x plus 10y equals negative 2. To find their slopes, we have to transform the equations into their slope-intercept form, y equals mx plus b. So we have here our first equation. In order to transform this into its slope-intercept form, we have to transpose 2x to the other side of the equal sign, giving us 5y equals negative 2x plus 3. Next, to cancel out 5 and 5y, let us divide both sides by 5, giving us y equals negative 2 over 5x plus 3 over 5. And notice that our equation is now in the form y equals mx plus b. And with that, we can now determine its slope, which is negative 2 over 5. For our second equation, we have 6x plus 10y equals negative 2. Same process, transpose 6x, giving us 10y equals negative 6x minus 2. Next, divide both sides by 10, leading us to have y equals negative 6 over 10x minus 2 over 10. Since it can still be simplified, we can now have y equals negative 3 over 5x minus 1 over 5. And our second slope is negative 3 over 5. Next, to determine their relationship, two lines are said to be non-perpendicular if their slopes are not equal and that their product is not equal to negative 1. So the relationship between these lines are non-perpendicular since their slopes are not equal to one another and their product is not equal to negative 1. Next, for number 2, we have x minus 5y equals negative 7 and 5x plus y equals 1. For our first equation, transpose x, giving us negative 5y minus x minus 7.
To cancel negative 5 in negative 5y, divide both sides by negative 5, leading us to have y equals 1 over 5x plus 7 over 5. And now its slope is 1 over 5. Same goes with our second equation. Transpose negative 5, giving us y equals negative 5x plus 1. Since it is already in a slope intercept form, the second slope is negative 5. To know the relationship between these lines, two lines are said to be perpendicular if the product of their slopes are equals to negative 1. So 1 over 5 times negative 5 is equals to negative 1. Therefore, these two lines are perpendicular. For number 3, we have lines 5x plus y equals 1 and 2x plus 5y equals 3. For our first equation, transpose 5x giving us y equals negative 5x plus 1 and its slope is negative 5. For our second equation, transpose 2x giving us 5y equals negative 2x plus 3. Divide both sides by 5 and now we have y equals negative 2 over 5 x plus 3 over 5. And the second slope is negative 2 over 5. The relationship between these lines are non-perpendicular since their slopes are not equal to one another and that their product is not equal to negative 1. For exercise 7, determine the angle between these pairs of lines with the use of formula. So for number 1, we have lines 6x plus 10y equals negative 2 and x minus 5y equals negative 7. First is to find their slopes. Same process as kanina. Transform the equations into their slope-intercept forms for us to determine their slopes. And that is negative 3 over 5 for our line 1 and 1 over 5 for our line 2. Next, to determine the angle between these lines, we are going to use the formula tangent theta equals the absolute value of m sub 2 minus m sub 1 over 1 plus m sub 2 m sub 1. Next is to just plug in the values accordingly, leading us to have tangent theta equals the absolute value of 1 over 5 minus negative 3 over 5 over 1 plus 1 over 5 times negative 3 over 5. Next is to just perform the given operations and that leads us to have tangent theta equals 10 over 11. Next is to transpose tangent to the other side of the equal sign, which will now be the inverse tangent of 10 over 11, and that is equals to 42.27 degrees. Last is to get its radian form. We will just multiply 42.27 degrees to pi over 180, and that is equal to 0.738 rad. Next, number 2, we have lines x minus 5y equals negative 7 and 2x plus 5y equals 3. Same steps, find their slopes by transforming them into their slope-intercept form, giving us our first slope to be 1 over 5 and the second slope to be negative 2 over 5. To determine the angle between them, use again the formula. Plug in or substitute the values accordingly, giving us tangent theta equals the absolute value of negative 2 over 5 minus 1 over 5 over 1 plus negative 2 over 5 times 1 over 5. Perform the given operations and now we have tangent theta equals 15 over 23. Next, next is to get its inverse, leading us to have theta equals 33.11 degrees. To get its radian form, multiply it by pi over 180 and the answer is 0.578 rad. Lastly, we have 5x plus y equals 1 and 6x plus 10y equals negative 2. Same steps, find their slopes by using their slope-intercept form, giving us our first slope to be negative 5 and second slope to be negative 3 over 5. To find the angle between these two lines, use again the formula and plug in the values accordingly, giving us tangent theta equals the absolute value of negative 3 over 5 minus negative 5 over 1 plus negative 3 over 5 times negative 5. Then perform the given operations, leading us to have tangent theta equals 11 over 10. Get its inverse tangent, which is equal to 47.73 degrees, and its radian form is 0.833 rad. That's all. Thank you.